All right, hi guys. I'm here to teach you about day 5, radians. Woohoo! So we are going to start making the day 4 flashcards. If you haven't made them yet, let's just make them. So here is the area of a sector. We'll use these at Regents time. The area of a sector from last class is A equals, at any time if this is going too fast, obviously just pause it, okay, and then come back. So there's your formula for area of a sector. Remember, this is just your area formula. You actually get that on the formula sheet, and then that's the fraction of it. And then if you have your arc length, as long as your angle is in degrees, which we're going to talk about that more today, to find the length of that arc, you would do n over 360, whatever fraction you want, and then you'd be using the circumference formula times 2 pi r. And this would, of course, give you the length of that arc AB, so length of AB. And that's just a fraction of your circumference formula. Okay, so those are the day 4 flashcards. Let's get going on day 5. Oh, here's the homework answers to day 4. Yay, you can check them out. 23 centimeters. Pause the video, write them down. If you have to try them again, 77.75. 2 pi. 6,000 pi. Oh, this last one's awesome. Should have been 40. It's a cool one. You got that. That's great. 6,000 pi. That's a Regents question. Okay. So right now, if we want to know the length of an arc, we need to know how many degrees this is, right? Like 150, we'll say. And you also have to know the radius. So you have to know the central angle in degrees. And you have to know the length of the radius. And in order to find the length of the arc, you would be doing what we just made the flashcard on, right? You would be doing, if this is 3 inches, you'd be doing 150 over 360 times 2 pi r to find the length of that arc AB, length of AB. So today we're going to find a different way to find arc length, and we're actually going to find a new way to measure angles, which is really cool. So in your notepad here, sorry, I had to find a note packet. In your note packet, go to page 31, and we're going to find a new way to measure angles. This is really important for honor students especially, because in your future, like when I took college level math, almost nothing is measured in degrees anymore. So radians are really important as you move forward into higher level math. So we've always measured everything in degrees. Now it's like we're going to measure things in radians. Well, what is a radian? So we're going to watch a really exciting video. I'm kidding, it's not exciting, but it is funny. About a radian. So here, what is happening in this video is they are taking the exact length of the radius and they are marking that off along the circle. So if the radius is 5 inches, then they're measuring an arc length of 5 inches. That angle right here that intercepts one arc of 1 radius is 1 radian. This is 1 radian right here. So my question to you is, maybe take a guess as to what you think. How many degrees is that, 1 radian? The most common guess I get is, hey, it looks about 60. You guys agree it looks to be about 60 degrees? That's a good guess. So then if 1 radian is 60 degrees, then that means how many of them should fit in half the circle then? You're thinking 3, right? And that's what the most common guess is they say, okay, see now here's 2 radii in the arc. This is 1 radius, 2 radii. So this angle now is 2 radians. Radians literally tell you how many radiuses fit in the arc. That's what a radian is. The angle that intercepts that number of radiuses. The angle that intercepts the arc of that many radiuses, radii. So notice 3 didn't work. It's a little more than 3. What is it? A little more than 3 radii fit in half the circle. You might have guessed it by now, but it's exactly pi. Pi of them fit in half the circle. Of course, our favorite number, right? 3.1415, that's all I got. So, yeah. So if a little pi of them fit in 180 degrees, then how many of them fit in 360 all the way around the circle? It's 2 pi, right? Did any of you ever wonder why your circumference formula was 2 pi r? Now you know. It's literally because 2 pi radii, fit around the circle. Isn't that fun? How fun. Do you think we need to finish watching the video just for satisfaction? Probably. So then here's 5 radians. These angles are the radians, remember. Okay? 1 radian, 2 radians, the angles of 2 radians, 3 radians, 4. So basically what you're going to see is that these radians simplify finding the arc length big time. It makes finding the arc length really, really easy. Cool. So we're done. We just saw that it's a little more than 6 of those. Okay. So now we are going to go back to our notes. And so we just saw that one, I think we are skipping to right here. It says 1 radian is equal to the central angle that subtends an arc length of 1 radius. And we saw that exactly 2 pi radians, which is about like 6.2 radiuses, right, fit around the circumference of an entire circle. So I'm going to have you skip to page 35. And don't worry, we'll come back to the other stuff. So on page 35 here, what we're going to do is we're going to use this to find arc length. So now I have a circle that has a radius of 6 centimeters. And the central angle is 1 radian. So if my central angle is 1 radian, unfortunately there's no abbreviation for radian, then what is the length of the arc? Well, it's 6 centimeters. Why? Because 1 radius means that there is one radian means that there's 1 radius in the arc. So there it is, 6 centimeters is your answer. I want you to pause the video and I want you to try the rest of the page, including writing the formula by yourself. And then I will fill them in. But if you were in class with me, you'd be doing this on your own. So please finish the page. Okay. Okay, sorry, I just realized I didn't ever pause it. But there's the first three worked out, and then your formula should have been your arc length is always equal to your angle in radians times your radius. You could have, of course, had r and the theta in different order since you can multiply them whenever you want. But this is the arc length equals the angle in radians times the radius. So there is your formula. You'll hear this referred to as the SOAR formula since it looks like SOAR from math teachers. But this is what you use to find arc length. So on the next page, the key concepts, a radian is the measure of the central angle that intercepts an arc equal to the radius. And then you can determine the length of the arc by the formula S equals theta r, where this is the arc length. And this is the central angle, except it has to be in radians, right? This doesn't pertain to degrees. So you can only use this formula, only use when you have radians. So think about it. Do degrees tell you how many radiuses fit in the arc? No, they don't. But radians do. So that's the difference. That's what this formula is saying. And this, of course, is the radius. We'll fill this out later. The 1 radian equals and 1 degree equals, okay? Okay, so let's try one here. You can pause the video if you want to try it on your own, or you can do it. You can use the formula or not use the formula. People can do it without the formula, especially honor students, but you can use it if you want to. So the radius is 6. It wants us to find the angle in radians. That's our theta. And the arc length is 4.2. So when you divide by 6, you should get theta is 0.7 radians. This one, notice, is in degrees. So if it's in degrees right now, we're not using SOAR. So if it's in degrees, central angle of 60 degrees intercepts an arc whose measure is 18 inches. So if I'm in degrees, what we're going to be using is they give you the arc length is 18 inches. We want to find the radius. You should be using your formula from the flashcard that we made earlier, right? This is our formula for degrees. It reminds you it's with degrees because 360 is degrees. So I'm going to plug the 18 in over here. And again, the reason I'm not using SOAR is because we don't have radians, so we can't use SOAR. So now, last time we had this situation happen, we had pi's on both sides of the equation that could cross off, but that's not the case here. So you want to do, first I'm going to multiply both sides by 360 to just get rid of this. Okay, we get 6,480 equals 2 pi r. Oops, we still have a 62. So now I'm going to divide both sides by 60. You can, of course, solve this in a variety of ways. Do this however it makes more sense to you, makes most sense to you. When you get here, you have to divide by both the 2 and the pi. In your calculator, you want to make sure that that's in parentheses when you do that, or use the fraction button to make sure you have numerator in this whole 2 pi in the denominator. Otherwise, you're going to get the wrong answer. The correct answer for the radius should be 17 inches to the nearest inch, 17 inches. Okay. Now let's do some SOAR practice. You should pause the video and you should try this page on your own. It's all radians. So please pause the video and I'm just going to fill it out. I'm going to pause it this time for real. Okay, quick answers, and I'm just going to scroll through my answers, and if you need to pause it and go back to one, you can. So 8 inches, should have gotten 12, 4, and 2.79. Woo! Okay, these are all tricky. We're going to come back to these, I think, after we do the converting. So what I want you to do now is I want you to go back to the top of page 32 in your notes, and we're now going to talk about How do we switch between the two? How do we switch between radians and degrees? In all honesty, in geometry, I never switch between the two. I only, if it's degrees, I use the circumference formula, and if it's radians, I use SOAR. However, in your future, you're going to want to be able to comfortably switch between the two. So that's why I'm going to do it here. So this is what we saw in the video. So from the video, we saw that 2 pi radians is equal to 360 degrees. So if I want to know how many radians are in 1 degree, what I'm going to do is I'm just going to divide both sides by 360 to get 1 degree. And I get that 1 degree equals 2 pi over 360 radians, which of course I can reduce. 2 over 360 is the same thing as 1 over 180. So pi over 180 radians equals 1 degree. Okay, so if you do in your calculator what pi over 180 actually is, oh God, I don't know how to use this thing. That's not gonna work out. We got to use the Smart View. Is it gonna open it? Here. I don't know how to use that other calculator. It's just a standard calculator. I should be able to figure it out, but I can't. Okay. So pi over 180. And you can see that it's about 0.017 degrees, which it makes sense if it's a really small number of degrees because it's a very small angle, 1 degree. So yeah, it's a very small number of radii. Very fraction of a radius. Okay. So now we want to go the other way. How many degrees are in 1 radian? So what we're going to do is I'm going to divide both sides by 2 pi. And all we're doing here is coming up with our conversion factor. So now I know that 1 radian is 360 divided by 2 pi degrees, which is the same thing we can reduce just like last time. That's the same thing as 180 over pi degrees. So in your calculator, I'm going to go back to the calculator if I can handle it. And notice if I do 180 divided by pi, ooh, this is small and hard to use, folks. Can I handle it? Okay, it's about 57 degrees. So we're close with our guess of 60 at first. We weren't terribly far off, but so this is, these are our conversion factors. Now, good news, you don't have to be able to generate those yourself. That's just where they come from. They're on your formula sheet. You can print one of these offline if you just Google New York State high school math reference sheet. Here it is. So you can print one for yourself, or you can just use this one. Keep pausing the video and going back to it. But these are what we just came up with, and it gives you them on your formula sheets. Okay. Okay, so we're going to practice converting. So if you're going to convert 150 degrees to radians, what you want to do, you want to start with the degrees ones. And 1 degree has this many radians in it. Well, that's just your conversion factor. So what we're going to do is we're going to multiply by this because 1 degree has this many radians, and I have 150 of those. So I'm going to do 150 times pi over 180, and that's going to give me this in radians. Now, we're multiplying these things. So you multiply the tops, multiply the bottoms, and then you should reduce. So it says give your answer in terms of pi. So I'm just going to reduce this out in front. You can do that in your calculator as well, but it's 5 pi over 6. If you reduce radians, and then it wants you to also be able to give your answer to the nearest 10. You should be comfortable with either one, which is about 2.6 radians. And we saw that, like, we know that pi radians, a little over 3, about 3.14 radiuses fit in 180 degrees, and this is 150. So our answer makes sense that it's 2.6 radians. Okay. 300, you can pause the video and try that one on your own. Okay, answer 5 pi over 3, 5.2 radians. Now, if we want to go the other way you should be multiplying by the other conversion factors. Now, if I go back to my formula sheet, We now have radians to start with. So whatever you start with, you look at that. So I'm starting with radians. Now I want to multiply by 180 over pi. So now you multiply by the reciprocal of what we were multiplying by before. And notice now these pi's cancel off, and this is a nice number. This is 45 degrees. I kind of expect my honor students to be able to calculate some of these easily without doing all this out. So bear with me for a second. We agree that this is, we know that's 180 degrees, right? So if you're going to convert it, when you see a pi in there, then this should turn out to be a relatively nice number, and some of them you can even do in your head. So certain ones that you should know without doing anything and just quick have reference. So 180 degrees divided by 4, we should know that's 45 degrees, pi over 4. So before we come to this one, what if I gave you like pi over 2? What's that one in your head? Pi over 2 radians is how many degrees? You should be able to just quick give me the answer. It's 90, right? 180 degrees divided by 2 is 90 degrees. What about pi over 3 then? What would pi over 3 radians be? See if you can get it without me. Yeah, 60. So then what's another one we should know? Pi over 6. It's 180 divided by 6, right? That one's 30 degrees. What if I give you, because then it gets cool, like what if I gave you 2 pi over 3 radians? Can you do that one? Because then that's 60 degrees, pi over 3 is 60, and then times 2, this one would be 120 degrees. Okay, sorry, that's just me being nerdy and fun. But next, 3, you can pause the video and try it on your own if you want. Go ahead. That one should have been about 171.89 degrees. It doesn't turn out to be nice. It's on the pi in it, so it's going to be irrational. Okay. There's a lot more practice here. I'm going to pause the video and just write in the answers for you to the rest of the practice problems. Okay, so that will be the end of the video. I'm just going to go back and write in the answers, and then I'll scroll through. So you guys should be finishing the day. Okay, I'm just scrolling through answers. You pause the video if you want to spend more time checking than I'm spending. Sounds kind of cool. These are a little harder, 4 and 5, good challenge questions though. All right, so now I just have to go back to these ones that we didn't do earlier. 9 and 10 are the last ones that we have to do in the day. So pause the video and try them. For this one, you can't compare arc length without the radius. So just angle measures, just because it's a bigger angle doesn't mean it's a longer arc. This one is 120 degrees if you convert it, and this one is 190 times 3, 270 degrees. So even though this is a bigger angle, it doesn't necessarily mean it's a bigger arc, because 270 degrees could be a really tiny circle, and then my 120 degree could be a really huge circle. So therefore, this arc could be longer than that arc. Okay, so that's not enough information. And this one you should have done n over 360 times 2 pi r. You could have converted to radians and used SOAR. Again, as I mentioned before, converting is more for the future. I always just go with what I have here. If I'm given degrees, then I go with degrees. So that should have been your answer there. Okay, yay, good work, you guys.